go ahead and turn things over to Pat Spencer, who's going to be introducing the team. Thanks.
Chris, thanks a lot. Really appreciate the introduction here. And want to welcome everybody to today's webinar. As Chris mentioned, this is some exciting stuff that's taking place within our industry today. And so excited to get our speakers introduced to you and get them started here. First, I'd like to introduce John Gray. He is Chief Technology Officer for Infinity. John has almost 30 years of experience aligning business strategy and IT operations across a wide spectrum of industries. John's worked in progressive technology environments from mainframe to the web. He's also designed numerous application and systems integration architectures as part of multi-million-dollar initiatives for both the public and the private sector organizations. John was also an early cloud adopter, and as such is respected within the industry as a thought leader in both cloud and emerging technology. So certainly we'll learn a lot from John today. Then secondly, we have Ananth Gopalakrishnan, who is Chief Technology Officer of SeyVu, and he has been driving deployment of complex and innovative data science solutions across several industries. So let's just say very, very smart in math, I would guess. Ananth has over 20 years experience in the semiconductor industry, and specific over the past decade, he is responsible for running an innovation team that was centered around data-driven capabilities in graphics computing. Now, under his leadership, the team streamlined development of pioneering solutions in design, test, integration, and proliferation of technology products. He is a proven leader and has managed large cross-functional global teams. So again, two gentlemen with great levels of experience. So let's get started on what we're going to talk a little bit about today. So we started off with something just a little bit funny, just to really kind of introduce the mindset here. So let's solve this problem by using the big data none of us have the slightest idea what to do with. And believe it or not, at InterVision, I manage our strategic solutions team. And we engage with clients to really help them on their journey. And what we have seen is really this type of conversation taking place with regards to their business, where they're currently at and where they want to go. And what we're going to learn today from both John and Ananth is really about what are some use cases of folks in the situation and where they've had the ability to go. So with that, let's talk about the topics that we're going to be covering today. Obviously, the landscape, what's taking place within the industry, and then what about the strategic value? So this is about technology, it's about analytics, but what's the strategic value for the business? And then certainly some use cases where really the rubber meets the road and what has been done to assist organizations moving forward. And then also we'll talk about the differentiation and the approach as well. And so with that, I'd like to turn it over to John and Ananth.
Thanks, Pat. So yeah, John Gray, I'm the CTO of Infinity. Been in this line of work for quite a long time, and I've really started to see AI, artificial intelligence, machine learning, predictive analytics come to the forefront here recently. In 2017, there was $12 billion spent in this area, expecting it to be, the predictions are $58 billion by 2021. And the really interesting statistic here to me is now in 2018, 61% of organizations picked machine learning predictive analytics as their company's most significant data initiative for the next year. So a lot of money being spent and a lot of focus on this area. So definitions. What is machine learning? Machine learning and artificial intelligence have become kind of synonymous really recently. So machine learning involves algorithms that build a mathematical model using sample data as training data. Very different from traditional software engineering. And we'll talk more about that later, but it's really about making predictions and decisions without being explicitly programmed, to perform a task. And used in a lot of areas, we've done a lot of work in this area around fraud detection, text analytics, security monitoring, where it's really completely infeasible to develop traditional software in those areas. So predictive analytics is an extension of machine learning that makes predictions about the future or otherwise unknown events. So predicting what's going to happen in the future around identifying risks opportunities, trends, behavior patterns, things that can be very, very powerful for organizations. Where will most machine learning predictive analytics occur? The answer to that is the public cloud. This is really what has fueled the exponential growth of machine learning and predictive analytics recently. Because artificial intelligence in general takes a lot of computing horsepower, a lot of compute, a lot of storage, a lot of memory, really to make it work effectively. And the cloud allows us to to get access in a very cost-efficient and time-effective way to a tremendous amount of horsepower, right? So kind of the theory behind it. Generally, these initiatives start out with somebody having a hunch. You've got a bunch of data. They've got a feeling that they can use that data. They come up with a hypothesis around a certain part of their business on how they might use that data. They get companies like ours with data scientists involved to do some experimenting, discovery, and produces an end result. So it's really more like scientific research than traditional IT initiatives, and it's very much focused on information, the I in information technology rather than the T so much. So, what does it actually involve implementing this? And this is where, we come in. We've done many of these projects, and these are projects that produce deliverables, right? So it's not sort of anything that's as great as all this is, you still have to follow a process, right, to get an outcome. So the projects deliver a solution. We follow a repeatable, defined process. Generally, we use the public cloud, and we use a lot of automation in building out environments and things like that so that, the projects go quickly and get off to, a quick start. We use a variety of machine learning predictive analytic tools. We've got some pre-built solutions that we bring to bear to speed things up. And in the end, you end up with working software. So, another way of looking at this is our repeatable process. Right, so we start out by defining the problem. Have somebody having a hunch, looking at the hypothesis, and then analyzing and determining, does that problem fit with the data that you have? So people have tons and tons of data now, but you really need to dig in and understand if the problem you're trying to solve can be handled with the data that you have. That may lead to some transforming, cleansing, enrichment of the data, and then starting to really look at how to apply the machine learning model, picking the right models, and Ananth will speak to this later. This is where your data scientists particularly become, absolutely, essential. It's very different to traditional software development. So, I can't stress that too much. My background is software engineering, computer science, whereas, for machine learning, you need data scientists, heavy mathematical background as opposed to developing algorithms, right? So once you get through the stage of training the model, then you go into the deployment of the model, which can then predict and then it adapts. That's one of the key things, obviously, about the artificial intelligence is the ongoing learning, right, that it keeps up with what's going on. And then quite often we end up in a situation where, we've focused on one area and we find something adjacent to it and discover more things. So that's where our company and our data scientists come involved to consult and advise. So again, the deliverable here is working software, which is models, analytics, and services. So it really sort of focuses on the strategic value of your data. And data is increasingly the most important thing that an organization has, right? It's what gives them visibility into the voice of their customer, for example. It's the data from the various different interactions from customers. It's then using that data to, do productive things to improve profits, to, retain customers, to ideally enable a competitive advantage. You can be sure that your competitors are starting to look at these areas, but if you can really sort of lay the groundwork and get ahead, you can leapfrog, and we've seen this, entirely leapfrog competitors. Security is, kind of job zero in IT these days, so we're always looking to improve and enhance in security, and pretty much every business is looking to increase sales, so predicting what people are going to buy in the future, those kinds of things, that is really a strength of machine learning. You know, as described there, you know, I am head of our cloud services division within InterVision. We do a lot of cloud migrations, right, from large on-premise data centers. Those can take many months. What happens, though, once we get through those, there are many good things that happen once we get out into the cloud. But once the data is out there, there are then tremendous opportunities to do machine learning, predictive analytics in a much, you know, faster way, because we can stand up the hardware, you know, in a much shorter time frame out in the cloud, and you know, really move in a much more agile way. So the tools we use, there's a whole variety, and, you know, that Ananth will describe some of these, and you know, a lot of them are open source, some of them are not. You know, we are partners and, you know, very skilled with tools like Splunk and Logarithm that are SIEM, you know, security tools that are adding machine learning packages that we're very skilled in. So, you know, there's a full array of tools, you know, libraries, languages, infrastructure, and visualization tools that is sort of ever growing and changing and becoming to some degree easier to use, like Amazon SageMaker is, you know, kind of a framework that provides a lot of things kind of out of the box. You still absolutely need the data scientists to really get anywhere with any sort of significant project. So, you know, what are the common client pain points that machine learning predictive analytics help with? Well, I think, you know, the statistic is that the amount of data being stored online these days is actually doubling every 18 months. You know, when you think about the amount of IoT, the amount of data that is streaming out of devices and being stored online, and the amount of data that organizations are now moving around, it is just mind-blowing. So machine learning predictive analytics really allows you to take advantage of that, to actually use it for decision-making, faster decision-making. If you're getting data, and most organizations are, you've got it coming at you from all different directions. How do you consolidate that data? You know, again, this is where, you know, artificial intelligence can help. And the environment we're in is, you know, I'm sure you're all feeling the pressure of rapidly changing environments. You know, we're in the cloud space and have been for quite a few years. The amount of change we see is just relentless, and it does not appear to be slowing down at this point. You know, the big players, you know, Amazon and Microsoft, are continuing to release new services at a relentless pace. So, you know, being able to keep up with that and apply those in your business, again, machine learning, artificial intelligence is an area of the industry that can really help. A lot of people are seeing higher error rates, you know, with their systems. Again, you can get ahead of it, predict things, and start to fix them proactively. Cost savings, obviously, is another area where we can apply these kinds of tools. So a lot going on, and I think, you know, some of the best ways to really sort of start to understand more about that is by looking at some use cases. So what I'll do at this point is hand you over to one of our data scientists who can kind of work you through a lot more detail here. So Ananth, over to you.
Thanks, John. And thanks, Pat, for the introduction earlier. So as John mentioned, he talked about machine learning, predictive analytics, you know, how it's starting to play a big role. And, you know, one of the best ways to showcase it in action is through use cases. So we picked a few use cases which we thought, are reflective of some of the things that we see in the industry, and also very interesting use cases. So there's plenty more, and we'd be more than happy to engage with you if you have a very specific set of problems that fit within, say, the set of triggers that John talked about. So we'd be happy to talk to you on that as well. So I'd like to start with the first use case. This is centered around fraud detection. This is you might have seen that, you know, fraud detection is a place where machine learning has been very effectively used across different businesses and sectors. It's been used in banking for bank fraud, credit card fraud, tax fraud, many different ways. In this particular use case, we're talking about application fraud within a community college system. So we have the California Community College System. This is the largest system in the nation, has about 115 independent colleges with about 2 million students that are actively enrolled. They get anywhere from 4 million, and I heard that last year was about 7 million applicants annually. So they were running into an issue where each of these colleges were getting spikes in the number of applications that they were receiving. And these colleges are all staffed by small admission teams, so they were largely overwhelmed looking at these application spikes. As they started to study this more, they realized that a lot of these applications were fraudulent. They never ended up resulting in students in seats in colleges. And what they realized was that the single purpose for a lot of this fraud was to obtain a digital asset, which is a .edu email address. With this email address, they were able to perpetrate downstream fraud, things like getting discounted products, free products, and going on to more complicated things like tax fraud and financial aid fraud, things of that nature. So we came in and we developed a system that would help address this problem for them. And in the next slide, I talk a little bit about that system itself. It's a continuous learning system that we've developed. So the diagram here kind of talks to the overall architecture. Before I start describing it, I want to touch on a couple of the stages that exist in machine learning as it pertains to putting something into production. So the first stage is essentially a training stage. This is where a machine learning model is presented with a curated set of data. In this case, the data is essentially applications from students. The applications contain many features, which are essentially the application fields. On top of that, we engineered several fields as well, which we thought would aid the model in learning the underlying signatures within the data. So what the model does at this point is it takes this curated data and understands the underlying signatures and to figure out whether an application is essentially fraudulent or not. Once the training process is done, a model is generated, right? So now I'll describe how exactly this process works. So when an application is submitted by a student, a request is made to our prediction service. The prediction service uses the underlying model and the data presented to it to make a prediction on whether the application is fraudulent or not. We also provide a probabilistic measure, a confidence measure, if you will, on how strong the model feels that it is fraudulent. If a model is indeed considered fraudulent, it goes into a suspend process. Essentially, the application is suspended for further review. In machine learning parlance, we call this architecture a human-in-the-loop architecture. What this allows us to do is have a human expert within the 115 colleges look at the application and verify that the model did the right thing. And this is especially useful early on because what this does is it applies a corrective factor to mistakes the model makes. The same thing happens if the model misses a fraudulent application. So it is later tagged as fraud, and that enters the system. And a subsequent training will capture these changes. And as a result, the model is refined over time, and it kind of continuously evolves over time. So this we deployed in September of last year, and it's been running. I think we've had about close to 1 million applications already go through the system. And by all metrics that we measure the performance of the model on, accuracy, precision, recall, the model has been performing above 95%. So it's been doing very well. This entire infrastructure was set up on AWS. The client had a significant presence on AWS already. And I want to add to what John was saying in his early slides. This is one of the places where the cloud really shines. Taking millions of applications and doing training on it requires a large amount of compute and memory resources. And this is something that the cloud is very good at. And on top of that, we applied the Infinity automation framework. What it allows us to do is at the point where we want to initiate training, we will quickly build out a large environment, perform training, and once the training is done, destroy the entire environment. And so the client only pays for the duration for which the training service actually occurred. So it's a significant cost saving for the client. For this particular client, we built a daily model retraining routine. That's not to say that you could do it more frequent or less frequent. It's essentially a design that is subjective depending on the use case. The predictions are live and fast. It happens in milliseconds, and as I mentioned earlier, it's a continuous evolving system. This is extremely important because before the system was installed, the IT teams and the admissions teams across these colleges were scrambling to basically address this fraud, and a lot of resources were expended towards this activity. Now, once the system has been in place, all of that wastage is gone, and the teams are able to be more productive doing what they're supposed to do in the first place. So with that, I'd like to move to my next use case. This is centered around text analytics. We've done a lot of work for different clients around text analytics, and so I've summarized some of the most common trends that we've seen within this space. That is not to say that this is the only use cases. There's plenty other use cases where anywhere where there is unstructured data. But I'd like to start with, say, social media tracking for brands or products or companies as a whole. That's an interesting use case. People like to understand how people perceive their brand or product in, say, microblog sites like Twitter or Facebook and places like that. There are companies which have embedded market research teams, and they do a lot of surveys trying to understand, feel the pulse of their customer. And there's a component of these surveys which is unstructured, essentially the textual data, which they have great difficulty in being able to quickly come to a conclusion on or generate actionable insights. And this is a great place where text analytics helps. And obviously, call center analytics, you want to be ahead of the curve in terms of understanding, what your customers' pain points are, what they're feeling. You want to be able to understand how that shifts over time or different windows of time. And this is a great place where text analytics works as well. So below here, we have a visualization of a generalized pipeline that supports some of these activities. We've done different variants of this for different clients, and obviously when we work with specific clients, there's a lot of customizations that we do to cater to their specific need. But in general, the way it works is you have a data source off on the left. The data source can be a public data source like a microblog site. It could be internal data sets like log files or data that's stored within your databases. But essentially, there's an ingest engine that consumes that data and presents it to a data preparation layer. The data preparation layer essentially isolates data that's interesting to this specific problem, largely unstructured textual data. And it also performs numerous natural language processing steps to prepare the data for subsequent machine learning engines to work on. At the end of this is essentially a visualization. The visualization is interactive and it's layered. So it starts with a high-level view, and people are able to break down and study the data or information more closely. Now, there are cases where such a pipeline feeds into a larger system. For instance, a portfolio manager might be interested in studying, say, the brand perception of a stock on Twitter. So in cases like that, the output is essentially a set of factors that is introduced into a larger set of algorithms that they want to study, basically do portfolio decisions on. In cases like that, we build, and this is a customization that I talked about, we build backtest generators. So they're able to study the outputs of these models and see how well it worked in the past and, do adjustments and so on. So these again are, this particular example is built on Azure, but it can very well be built on any other cloud platform. We build them in such a way they're highly configurable. And in most cases, we build them as on-demand engines because sometimes the data set is large. So the computational needs of this entire pipeline can be very high, in which case we want to basically construct and deconstruct and use only during times when you want to have it running. I will talk a little bit more about the machine learning engines itself in my next slide. So as I mentioned, we've done a lot of work in this space with different clients, and so through this process, we've essentially built a text analytics framework that we call TextSENSE. So here's a visualization of that. At the lowest level, you have the data ingest layer. For standardized ingest points like, say, Twitter or Amazon reviews and things like that, we already have modules that we have developed. For other sources, like, internal company databases or logs, we will develop the custom blocks for that. And then we have a series of, machine learning libraries that we've developed, and we continue to develop and evolve. And I'll walk through them, each of them. So the first is essentially a sentiment analyzer. This, as it says, it analyzes the sentiment in the unstructured data. How do people feel about, a specific, say, product or brand? And you might notice that there's plenty of sentiment analyzers in the market. We go well beyond what the typical sentiment analyzer does. We're able to, like, for instance, if I take two specific comments about a given product, say one user says the product is good versus the other user saying the product is awesome. A typical sentiment analyzer will both classify will classify both of these text elements as positive. However, we're able to distinguish the excitement level that is captured within these two comments, and we're able to kind of visualize that for our clients. Another is essentially an attribute analyzer. So we're able to dig in further on sentiment analysis. For example, a brand manager might be interested in knowing the perception of a product with respect to a very specific attribute, say price or customer service. And we're able to basically isolate content that speaks to those specific attributes and perform sentiment analysis on them. And then we're able to study heat maps that basically look at the spectrum of sentiments and how the level of excitation, both on the negative and positive side, and gives kind of great level of insights on how people feel. So it's instead of a black and white picture, you get a much more nuanced picture of how people feel about your product or service. And then we, on the right side, we have a couple for the quintessential analysts who would like to really dig into the data. So we have word network analyzers, essentially like a word graph that visualizes word co-occurrences, and people are able to do a lot more interactive study with that. Lastly, we have a cluster engine, which is a thematic analyzer. It's more of an open-ended analysis, if you will, of the data set, which can be either just, you can isolate it by positive comments and negative comments, and then look at what is the general theme of how people feel about my product. What are the different buckets that you would, group the different comments in, and so on. So the final layer is essentially the customization layer, and this speaks to this specific vertical for each of these applications. So somebody who's looking at brand monitoring will have a different set of KPIs to somebody who does market research, and we build custom visualizations to support each of these verticals, if you will. So we have something that's already developed, and we'd be happy to share a demo in greater detail with you. Please work with Pat if you'd like to study this more. So moving on to the next use case. So I lied when I said all of my use cases are machine learning. One of them is actually business intelligence. And I want to talk about why. When we talk to different clients, they are, each of them falls in a different point in their data journey. So some of them are fairly advanced. They have data lakes, data marts, and different data infrastructures, and they're just ready to go in and apply advanced machine learning and predictive analytics tools. Others are a little bit earlier in the pipeline, and they're just beginning to kind of understand the power of the data and try to see how they can leverage it. So this is an example of work that we're currently doing with a semiconductor client. This is actually within the IT team within this client. And in a semiconductor company within the IT team, some of the biggest cost drivers are one is licensing costs for design automation tools, and another is essentially computational resources, because semiconductor development jobs are very compute and memory intensive. So this particular client had data centers across different places, different geographies. They have different sets of teams, many different projects, and many kinds of jobs. And they never could get quite a good handle on how their resources are being utilized, or whether their resources were being utilized in an effective fashion. So we architected essentially a business intelligence pipeline, and this kind of sort of looks very similar to the text analytics pipeline I talked about. On the left, We have the data sources. In this case, they had data sources sitting in different IBM databases. So we have an ingest layer that essentially prepares, that collects the data and presents it to a preparation layer. The preparation layer focuses on elements that are most interesting to the client. In this case, they wanted to study, how their licenses are used, or computational resources are used across, different vectors like geographies, projects, time windows, and things of that nature. So at the end, we'll have an interactive dashboard which is built on AWS, where the team can really study and understand the underlying patterns within their usage. Now, the reason I bring this use case up is it is easy to see that once you have something like this in place, it is really an incremental effort to use machine learning or predictive analytics to generate significant business value. In this case, it's fairly easy to build a predictive model that suggests, a projected license usage or computational growth over time, so over the next quarter, over the next year, and so on. And this would be a significant tool in the arsenal of somebody who's managing the IT's purse strings, if you will. And this is where, when John talked about the last stage in our repeatable process, which is discover, we're happy to come in and look at people's data and help them along their machine learning journey. So moving on to the next use case, and this would be my last use case. This is centered around customer segmentation. This is again for a semiconductor client. This is Lattice Semiconductors. They are a semiconductor manufacturer of field programmable gate arrays, FPGAs. So they had customers across 8 different markets, and they possessed web traffic data of their clients' interactions. So essentially, this is data where a client would come to their website, they go to different sub-pages, they would look at different design documents, they'd look at download different data sheets, download software, things of that nature. Now, they had about a third of their customers, self-identified, but the rest, they had no clue as to what market segment they belong to. So they had a hard time, targeting these people. And this is especially an interesting problem because FPGAs are generic in nature, and in many cases, a single FPGA product could serve multiple, if not all 8 of these markets. So it was a difficult problem to solve. So in our implementation, we came up with a creative multi-class machine learning solution. So when I say multi-class, it essentially predicts 1 of 8 different market segments. And this was really interesting because we had to take some creative hybrid approaches. Some of the data that we had in the web analytics was essentially machine-generated text data. And so we integrated some natural language processing techniques within this approach to be able to come up with high-performance results. Now, this is also a case where, not only did we present a single solution as to basically predict a single market, but we were able to come up with some sort of a prescriptive approach. And this speaks to the problem definition itself. The underlying goal for Lattice Semiconductors was to be able to have the maximum, focused reach possible to their unidentified clients. So we created a prescriptive solution that was essentially a tiered strategy. So in cases where the machine learning model was highly predictive, we provided a single market solution. In cases where the predictions fall within a certain band, we made predictions of the top 2 or 3 markets. And then in cases where the model was really having great difficulty, we just did not make a prediction. And in the end, that was about only 2% of the identified customers. Now, with this, they were able to get a lot more targeted in their newsletters. For instance, for those where there is a high degree of precision, they were able to target them with a very specific market. For the second tier, they were able to essentially target a hybrid newsletter, and for the last 2%, they provided a more generic newsletter. And they essentially saw a 200% increase in the identified population, and right away, right off the bat, they were able to see a 20% increase in their email open rates. Essentially, because their newsletters were more targeted, there was a lot more interest, and people started to kind of get more engaged, if you will. So on top of this, as we went through the process, we understood their overall design, and again, we were able to advise and consult with them on essentially improving their data quality. So we talked about we enabled them with strategies that would improve the precision of the data that they collect, thereby continuing to improve the precision of the model that we have in place today with them. So that would be the last of my use cases. I'm going to hand it off to John to continue.
Thanks, Ananth. So I think hopefully those use cases really give you a good idea of a wide spectrum of ways that machine learning, predictive analytics, and even traditional business intelligence can be applied, right? So I want to wrap up by kind of talking about the differentiation of Infinity and InterVision within this market. I think you can tell, we've got a lot of experience in this area. With Ananth and his team of data scientists, we've got a proven track record of being able to apply, our expertise in a very practical way to produce good outcomes for clients. We are, neutral on the technology we can use. As you've seen, we've done this work in Microsoft Cloud, in AWS. We can do it on-prem if needed as well. We tend to end up being trusted advisors with our clients and get asked back to do more work for them. And compared to many of our competitors, we're very affordable. So overall, this gives a very strong differentiation, a very strong package for us as a company. And we're seeing increasing activity, which is obviously great, and doing work in a lot of different areas, which is exciting for our team, and would love to get involved with you guys if it makes sense. So at this point, I will pause and see if we have any questions. Chris?
Yeah, John, thank you very much. And guys, everyone who's joined in with us today, please don't hesitate to keep your questions coming in. You can use the question mark bubble in your WebEx browser, or you can use the chat functionality, and I'll make sure that those get asked. But John, you touched a little bit on the first one here, but we have a health insurance company on that has some issues with compliance, and they want to know, if they were to leverage AWS, for example, how you keep the data protected, or if you would be able to do this in their environment.
Well, yes, we can do it in their environment, and if we do it in the cloud, and we are experienced at working with various healthcare companies in the cloud, setting up HIPAA-compliant environments. For example, with AWS, there's a subset of AWS's services that are HIPAA eligible. We've got a signed BAA in place with AWS, and we've done this kind of work for various clients. So the cloud is, for the reasons we described, is really the best place to do this kind of work. We can meet all the compliance regulations and do the work there, but if needed, we can also work on-prem. So.
Great, thank you. And so another question related to the repeatable process you guys walked through earlier. How do you kind of align that model with the specific needs of a business? And can you take a sample of the data and run like a proof of concept?
Yeah, let me give that one to Ananth. He's
sure.
He and his team are deep into this, so.
John, if you can flip to the process slide, the repeatable process slide, I can kind of use that as a backdrop as I talk through this, if you don't mind.
I can. Give me a second here.
No problem. So in short, yes, in most cases, we're able to kind of look at a sample of the data, but typically we have, in this process, we have built in several litmus tests, if you will, to study the whole idea of, is this something that will actually work? Like the very first case that we talk about problem definition, we try to frame the question. And at that point, we're basically looking at, okay, the first question we ask is, what kind of data do you have? How much data do you have? How far does it go? Is it clean? Things of that nature. And it gives us an initial preview, if you will. The second stage itself, the analyze stage, is when we really dig into the data. We do a lot of exploratory analysis with the data. And it kind of gives us a deeper insight, if you will, on how well a given data set is going to help with the problem. And in many cases, as you go through this step, the learning phase, we split it into two phases, a phase 1 and a phase 2. A phase 1 is basically just a real quick initial model that gives us an early indicator of how successful this approach is going to be. So we try to work it in such a way that, there's many litmus tests across the process, and we're constantly interacting with our clients to be able to tell them, what results you're going to get and so on. And in several cases, we build POCs with a smaller subset of data and so on. I hope that answers the question.
Yeah, I think so. And again, if it doesn't answer your question, just please feel to elaborate in the Q&A. We did have one more come in. John, if you could do me a favor and go to the end of the deck as well, just so people know how to get a hold of Pat. But as I'm pulling up this question here, so another question is, how accurate, it says, how accurate is this data, and then in quotation marks, high error rates, and how will it have an effect on the decision making?
Ananth, do you want to?
So I'm going to take a stab at this. I don't fully understand the question, but it really depends. It's very subjective, right? Different problems. For instance, I'll give you two contrasting examples. The first one is the fraud detection case that I talked about. Through our exploratory analysis, depending on the data set we had, we were able to find strong underlying signatures. So our expectations for model performance were significantly high. So our expectations for error rates were very, very low. In a case like a multi-class problem where you have to predict one among 8 different classes, and your data is a little bit noisier, you have to your expectations of what the model performance would be a lot lower, right? In which case the error rates would be a little bit higher. So it's really subjective, both based on what data you have and the type of problem you're trying to solve.
Great, thank you.
Let me add in a little there. I've been, having followed through on a number of these projects, I've been surprised how effective these tools and our team have been with data that I would have considered to be, not super clean. It's quite impressive how this technology can work, with less than perfect data.
And if I may add one more point here, so if you take the last example that I talked about, which is the customer segmentation problem, this is where we take a lot of effort in working with the customer, really understanding their domain, their use case, and essentially coming up with solutions. So we focus on essentially the prescriptive element, which is of value to the client. So the model predicts something, but beyond that, how can a client actually use that data, right? So in this case, with noisy data, we're able to come up with, a tiered approach. And in the end, it ended up being a very, very strong solution that we were able to put in place.
Great, thank you. Pat, I'm going to go ahead and turn it over to you just to talk a little bit about, if people are interested in today's conversation and have other questions or kind of want to take the next step, if you just wanted to jump in and let them know.
Absolutely. Thanks, Chris. Appreciate that. And John and Ananth, thanks so much. This has been a really, I think, valuable webinar. So to the group, what you've heard is, cases against fraud detection, text analytics, business intelligence, and customer segmentation. So really a varied, select group of projects. And then you also saw it against different verticals, being education and technology. So the answer is there's no one size that fits all, but you can also tell in the energy with John and Ananth today the desire to help you solve your problems. And that's really what it's about, and it's what my team works with clients to do, and certainly enjoy working with the folks at Infinity because of how they approach the projects with the clients. So if there is additional interest, would love to start the conversation. That's typically where it begins, and the focus will be on problem solving and moving your business forward. So just would ask you, if you would like to get a free preliminary assessment, reach out to myself. You have my email address there as well as my phone number. Certainly we'll look forward to talking with you. John and Ananth, I just want to thank you again for your time today. Chris, appreciate the hosting and the housekeeping and the questions. And with that, we will let everyone go. And again, if you have questions, please reach out. Thank you very much.
Thanks,
yeah,
Pat.
but again, thanks everyone. The recording of the session will go out, so you'll get a recording of that, and you can reply to that email if you'd like to set up a conversation as well. So just want to make it easy as possible for anybody who wants to continue the conversation. Thanks again for everybody for joining.